This problem is number 29 on page 143. We're looking at chapter 3.3. In this particular problem, caffeine, the following are the number of grams of carbohydrates in 12-ounce espresso beverages offered at Starbucks. So there is the data set. There's 22 measures, and hopefully it was randomly generated. So here are the questions in this particular problem. Find the first and third quartiles, find the median of these data, find the upper and lower fences, construct a box plot for these data. What is the 31st percentile? And the last one is there are 38 grams of carbohydrates in an iced dark cherry mocha. What is the percentile? So some of these, I've just taken some of the questions out of this problem just to show you how to do them. You may want to work the rest of the problem, number 29, to make sure you have the ideas. So to actually work the problem, and we notice that in the first four of these problems, they're asking questions about what the median is or the quartile is, and the upper and lower fences. And so we're going to use the TI 83 and 84 to do this. The first thing is we're going to enter the data in the stats key under the edit option. So you can put the data into, say, L1 under the edit option. Once you have the data in the 22 different pieces of data, you can press the stat key again and move over to the calculate option. From there, you choose the one variable stats and select the correct L column that your data is in. In this case, we may use L1. Find the 5 number summary is the next case. So once you put in one variable stats, hit L1 and hit enter. Now you can find the 5 number summary by using the cursor and moving the icon down until you see this screen. And now you can find the interquartile range, right, because it's Q3 minus Q1, and you can find the upper and lower fences. There's the formula for both of those. The lower fence is Q1 minus 1.5 times IQR, and the upper fence is Q3 plus 1.5 times the IQR. So in this case, we did that. The IQR appears to be 27, 41 minus 14, and the lower fence is a negative 26.5, and the upper fence is 81.5. So in this data set, there appears to be no outliers. Why? Because the maximum value is less than the upper fence, and the minimum value is greater than the lower fence. So we will use this information in the rest of the questions. So now, to answer the question, A, the first and third quartiles, we just look at our screen and we see that Q3 is 41 and Q1 is 14 and the median is 27. And we've already found the lower and upper fences. And now the idea is to construct a box plot using the TI 83. And to do that, we will press the second Y equal key, and we get the menu screen for plots. Once we have the first plot, the icon is on the first plot, we will hit enter, and we'll press on the on icon as soon as we get that plot menu. Move the cursor over the box plot icon with outliers. So there's little dots next to a box, we'll press that 1. We'll move the cursor down to the X list, and if our data is in L1, we will make sure that we put in L1. Leave the frequency as equal to 1. Once you've done that, then you can move over to the Windows key to set up the scales for the X based on the minimum and the maximum values for X. Also in this case, I always let Y min for the box plot to be 0 and Y max to be equal to 10. Once you've set up your scale, then you can press the graph key and you should get this particular box plot. You can see that there are no outliers. My whiskers, my maximum value is going to be 59, and my minimum value here is going to be 9, right? So we know where those values are at because they're whiskers and they are not outliers. If they had been outliers, we would have seen dots in the box plot outside the whiskers. So one of the questions asks, find the percentiles. So we're going to find the 37th percentile. We do this by sorting the data set. We can sort the data using the TI-83. And if we use the TI-83, you can use the sort function, sort A function, and then just put in, say, L1. But if you don't use the sort function, you can go ahead and use a stem and leaf plot, which I did here. I am missing one value, I noticed. I'm missing another 27, so I'm going to go ahead and put that in there. And so now the question is, calculate the location of the 31st percentile. To do that, we notice that to find the location, right, to find the location, we multiply 22 times 0.31. 22 is the number of observations in the data set. We had 22 of those, and we multiply it by 0.31, which is 31 divided by 100, which is the 31st percentile. That equal to 6.82, but since we have an integer, we round up to 7. Now we count from the beginning to until we get to 7 to find the 21st percentile. To do that, we would count 1, 2, 3, 4, 5, 6, 7, and we notice it's at 24. So our 31st percentile is at 24. The next question is find the percentile for 38 grams. Now here we have to do something slightly different. We count to where 38 is in the data set, and we find that there's 15 observations from the beginning to 38. So the location of 38 minus 1, 15 minus 1 is equal to 14, but we add 0.5 to that, okay, because it's greater than that, and we divide by 22 observations again. That gives us 65.9, which is a percentage, and technically we can round up to 66%. So the 38 grams is at the 66th percentile in the data set. Well, that concludes the problems in chapter 3.3. Please practice those, and we'll do problems starting in chapter 4.